Hello everyone, good morning. The project, the work I'm about to present, is a collaboration between myself, Jeroen van Bemmel, and my partner and wife, Paola Santoli. Unfortunately, she couldn't make it today here for logistic reasons. She apologizes, but she sent me to do the honors and to represent us in this forum. I hope to honor her, do justice to her thoughts and ideas, and any mistakes or like bad jokes, those are mine, but the ideas are also hers. As we saw also yesterday mentioned in the keynote speakers by DJ, most companies, especially the big ones, they tend to have targets for sustainability, right? Emission reduction targets. I list a couple here. So Google, for example, they're all fairly similar. They differ in details and scope and timelines, but Google will say, okay, we're aiming to do net zero by 2030, which is pretty aggressive relatively. Facebook or Meta, they say, okay, net zero by 2030, including scope 3. Amazon, a little bit later, 2040, and Microsoft, something similar, right? So that's all good, and this is what we want. But if you read their reports, you will see that actually last year, 2021, all these companies actually increased their emissions. 10% for Google, 11%, Amazon 18%, and Microsoft 21%. I was speaking to Don yesterday, and he said, are you going to get up on that stage and call out all those companies, those sponsors, on their emissions? And I guess I am. Because, and so before you like run to your lawyers and say, hey, this guy from Nokia is dissing us at this stage, there's actually two things. One, this is a very common problem, right? It's an industry problem. It's not just you, it's all your competitors as well. It's even Nokia and Ericsson. I didn't put them on the slide for obvious reasons, but they have the same problem. We're actually increasing our emissions. So this is a shared problem. And two, I have a solution in this presentation. So if you shoot me before I tell you, then so bear with me for another 7 minutes, and hopefully we can reach a conclusion on what we are about to do, what we can do about this problem, especially here in the OCP community. And so this is last year, so you may think, okay, 2021, that was we just came back out of the excuse me, the pandemic, so everybody got back to work, maybe 2022 will be better. Well, Meta in July said, well, we want to do 5 times more GPUs by the end of the year. And that's great because they need to compete, of course, with TikTok in their case. But 5 times more GPUs means also 5 times, or even more than 5 times, more emissions. Right? So companies, they have a target to say we want to reduce emissions, but they also have a target to make profits and to be competitive in the market. So there's basically a challenge. And the IEA, this is a global graph of CO2 emissions by GDP. There's a general trend, but the more economic activity you do, the more emissions you have. And that's it's almost like physics, right? It's hard to deny or to move away from that. So again, last year, 6% increase in emissions globally, 5.9% jump in GDP. So it's very much correlated. So there's a challenge. How do we grow as a company sustainably while we still reduce our emissions and meet those targets that we say that we want to achieve by 2030? And the general solution, I think, as a direction is heat reuse. Because the idea is if you're using the energy that you already spent and you're doing something useful with it, you're creating additional value without creating additional emissions. So it kind of makes sense that I think that's one of the ways, maybe even the only way, that you can grow while still being economically active and doing business. And of course, this is not a new idea. We have a heat reuse group here at OCP, But they focus mostly on data centers. And the problem with data centers is that most data centers are not designed for heat reuse, right? They are designed, typically they're located in a place where the power is cheap or there's a lot of good connectivity, but not located in a place where it's optimal for heat reuse. And even if you do modify them for heat reuse, it's very expensive. So most people don't do it. There are exceptions, and we'll hear about them today. Cloud and heat technology is one. But in general, on average, most data centers don't do it. And so what I'm proposing here, what the paper is about, is what if we take those compute resources, the CPUs, the GPUs that come out of those data centers. They use them for 3, 4, 5, 6 years, but then after that, there's still quite a long time, many years of usable life in those components. If we put them into appliances, like smaller appliances that you would put in people's homes, and design them for heat reuse specifically, we say, so that you can, instead of like a normal heating element, you would put a processor in there, and you use it to warm people's homes. That way, you can still do both, right? So Facebook can do, they can deploy their 5 times GPUs like they are planning to, use them in a data center in a concentrated way, and after they're done, contribute them to an ecosystem of smaller companies. It may not be Facebook themselves that are deploying this, but they will make it available to the community, work with the community, with the OCP to define these standards that enable these kind of appliances, these designs, so that you can build this heat reuse as a principle, as a general thing that you do by default. And then I think if you do that, and if you make it understandable to humans, so you say, okay, what can you do with, if you run a GPU for 6 hours, you can take a 15-minute shower, right? Make it understandable. What is the value of that heat reuse? Because I think today, heat reuse, most people don't see, okay, is it worthwhile for me to capture that heat, right? It's untangible. It's hard to capture how valuable it is. But if we define the standards and we define the use cases, and we promote the concept, and we say, look, we have this sustainability track for OCP, and our main principle of achieving that is heat reuse, both in the data centers and then after in the second life of those components, as we retire them, we put them into people's homes, and that way we can improve sustainability and build a better world for everybody. So in summary, more heat reuse is the path to grow. If we recycle the data center hardware, we can do that because we can move the components and put them near where the heat can be reused. And I think the OCP community, and especially those 4 companies, Facebook, Microsoft, Amazon, those big emission companies that say they want to reduce their emissions, those are in a unique position to make their recycled hardware available and work with the OCP community to recycle the hardware and do heat reuse for the greater good. And the window of opportunity to do this is now, because you have all these subsidies. There's all these companies in the Netherlands, for example. There is a great desire to move away from gas, natural gas, to move to electricity. So people are pumping out heat pumps and deploying heat pumps, but they're designing them in a way that is not optimized for some of the more systemic challenges, like, for example, the storage that you would need to make sure that not everybody needs to switch on their heat pump at the same time, because that creates other problems for the grid later on. And last but not least, I want to shout out to Carnot and ITRU. I think they're already doing a lot of what I'm talking about here. Maybe at a smaller scale. I did a calculation. If we build 23.6 million Carnot appliances, we can supply all the heat for Germany, in German homes, and that's about half the household, so I think that's feasible. But in general, I hope that this was interesting to you, and I welcome your questions.